So, as David said, I'm Michael Stanley and this is Harsh Panchal. And in December of 2020, we both took part in the NOAA and NVIDIA GPU Hackathon. So the overall goals of the hackathon were to essentially get existing products or programs running on NVIDIA compute. And there were 8 other teams, so they focused around getting mathematical models running on NVIDIA resources, and then using tools like DALI and NVIDIA Profiler to see how well the NVIDIA compute clusters improve their programs. So our team was a combination of Linker Analytics, based over here in New Zealand, and AI.Fish, who are based in California and Hawaii. So we took a slightly different approach from the other teams and did a traditional machine learning approach. So we did object detection, which is finding a fish in a frame, which was done by AI.Fish, and then image classification, which is then taking that cropped region of the fish and saying what species it is. So we chose this approach because we're an AI and machine learning focused team, and we like doing very environmentally beneficial challenges. And also I've got a good bit of experience working with the fisheries. So I've been working alongside NOAA for around 7 months doing underwater detection and projects around that. So I'm going to show you a quick example now. So this is unrelated to the hackathon, but this is some object detection that I did on the same data set that was used in the hackathon. So you can see it's probably not super clear for the guys of you way back there, but there's some boxes drawn around the fish here. So we ran it through, I think this is trained on 2K imagery on around 3,000 images. And so we've got pretty promising results. One issue that we had was detecting these mounds here as fish. So this didn't get as far as dropping those detections into species. So it was just single class, but so you can, hopefully some of you guys can see the detections there. Also, previously, Linker has done some, try and pull it up over here. So this is work done by David Knox previously. So it's object detection and classification paired with a video scrubbing tool. So I can just go through the video here, and you can see we've got some sandbags detected, the diver's gloves, and then it's also paired with the scrubbing tool at the bottom, so you can see the number of inferences made by the AI model at the bottom there. But both these projects were unrelated to the hackathon, and now Harsh is going to run you through the data for the hackathon.
So yeah, thanks Michael. So basically we know that without data there practically can't be any machine learning or data science applications as such. So the data basically for this hackathon was provided by NOAA, and they actually used a machine called as an autonomous underwater vehicle, which basically traveled across the south of Vancouver Island in the west coast of the US. So if you can see here, it basically follows a zigzag pattern. And yeah, so basically the autonomous underwater vehicle goes underwater and just, it's a pre-programmed path maybe, and then it tries to collect images and videos. So mainly for this challenge, we ended up using 4K images. So yeah, so one of the biggest challenges that we faced, or the highlight of the whole hackathon, or what we focused on, was that there was 0 annotated data. So basically we had no annotations to begin with. AI Fish, who ended up doing the detection system, used 4,400 images, a set of 4,400 images, and their developers basically sat across and used some tool to create 15,000 bounding boxes. And for the classification network, what we use is around 7,000 images. So basically, one single image has multiple, aquatic animals or fish species. And so the 7,000 images that we used were just bounded boxes bounded just to one fish species. So if there are 4 fishes, we get like 4 bounding boxes, chips, and that's how we got the 7,000 images. So this is a pretty low number. If you'll have been used to doing machine learning and AI, this is pretty low number to build a system. So we ended up using something that's called as active learning in machine learning. So basically active learning was one of the fastest approach with which we could build the data over time, and it will be explained in detail in the later slides. We did have multiple species, definitely. So there were short spine thorny heads, also known as idiot fishes, spotted rat fishes, sharks, urchins, and etc. and so on. but we decided to just classify 11 species in total for the classifier system for the given amount of time that we had. Yeah, we did definitely face some challenges. One of the main one was data and time constraints. Like I said, we did not have, like we had 0 annotations and we needed to make sure to build the system from scratch. And we did not have that many people to not use an active learning system and just end up, annotating the data all on our own. So yeah, that was one of the constraints. Domain knowledge. Definitely for any project that you build or you plan to build, you need to have some domain knowledge of it. Even though we have worked on previous projects, we have Michael who's worked on fish related projects, but we needed to understand what species existed in the data set. And that's where the NOAA scientists step in and they actually helped us create an error-free database. The data set also was very complicated. If you all can see over here, there are a few images. The second image over here is basically a flatfish, which is present over here. It basically belongs to a family of ground fishes. So ground fishes are fishes that lay close to the seabed and are actually very difficult to detect. Then some images had overlapping fish species, and then it was really difficult to count them. If you see, there are overlapping urchins and other invertebrates as well. So yeah, also, as I said, that the images that were used for classification network were bounded boxes, and so these images were specifically just one fish image, and they were brought down from 4K to 300 by 300 in that process, and that's actually a very low quality for a fish classification system. Some examples we'll show you later. And coordination with teams. So as Michael has already said, that the AI.fish was in California and Hawaii, so obviously there was a time zone difference, and to ensure that everything went in a smoother flow process, it was really difficult to manage the time. We obviously worked late nights for the hackathon just to ensure that the workflow was smooth. And also the hackathon was based out of US. They had a meeting first thing in the morning at their day start and end of their day. So the first meeting in the morning was 3 a.m. New Zealand time. So these were some of the challenges that we faced. I'll pass it on to Michael to explain the implementation details and other things.
Just quickly, who could actually see the flatfish there? Can you guys see it in the middle? Yeah, because this was a huge problem we had. It was even when we had the bounding boxes, just going through and saying whether the AI was right or wrong, very tricky because I can barely see that. But yeah, so the object detection system, which is done by AI.fish, they used a faster RCNN model, so all the models that we used are convolutional neural networks. And then the active learning system used Inception v3, so David Knox, he created the active learning tool, and he found through various means and on previous projects as well that Inception v3 was quite a good model for this kind of task. And then once we'd created a rather large data set from the active learning process, we used the EfficientNet v4 to then train a classifier. So EfficientNet is kind of the industry leader right now in terms of image classification. So as the name suggests, it's highly efficient. In the slides that I showed before with object detection, this was using an architecture based on EfficientNet called EfficientDet. And this allowed me to train on images that were 2K instead of 500 by 500, which is normally what we're able to do. So yeah, we chose B4 as well. So EfficientNet ranges from B0 to B7, and B4 is basically a good trade-off between the size of the architecture and then the performance. So we didn't want to go with something too hefty like B7, so B4 is pretty good for us. So the active learning process. So our Inception v3 model was initially trained on around 200 images, and then once we got the inferences from the object detector from AI.fish, so they sent us north of 7,000 inferences. So we then got their inferences, which were the boxes around the fish, and then cropped those out and then ran our weak model on it. So we used max entropy sampling and random sampling to then go through the inferences from our classifier that were least confident, and then we use a human-in-the-loop process to then correct these. So this is how the active learning process works, is that you're only training the model on what it's worst at, so that's why we could get it done so quickly, because we're not focusing on trying to make a ton of annotations, and we're only doing what the model really needs. So I'm going to run you through the active learning tool now. So here we go. So on the left we've got an image, and on the right we've got our classes. So you can see that the AI has predicted this as a rockfish with a 76% confidence, and that actually looks pretty good, so I'm just going to verify that by clicking rockfish on the right there. This again looks like a rockfish. That's definitely not an invertebrate, but I think that might be... Oh no, it looks like a starfish, yeah. So that could be correct. But then if I think that maybe it's a species that isn't part of the ones we want to include, then I can always put it down as unclassified remove. If we have images with more than one fish or just really unclear imagery, then we tend to discard those. So underneath the image here, you can see the number that we've done so far. So for the project, we did around 7,000, but you can see how many times we've gone through this rehearsal because there's around 7,400 now. And so the biggest class is discard. So we want to keep everything out that isn't really relevant or super clear, just to avoid training the model on something that won't help it. And then you can see the breakdown for the classes. So we've largely had rockfish and flatfish. And so as well over here, if I make a mistake and put this down as a sponge, I can always just undo the previous, which is pretty useful when you're trying to get through thousands of these at a time and you mess up a little bit. We also have a user guide, so if we're trying to train new people to use this tool, the user guide is really helpful. I've got it open already. So we've got the 11 classes here, and you can see each class. If I click on one of them, then you can see multiple images for the same class. So we've got a bunch of flatfish here, and then I just want to show you guys the most common one, rockfish. So we also had the short spine thorny head, which was pretty tricky because it looks very similar to the rockfish, and Harsh will cover this later, but yeah, it was hard for us to tell the difference. It was hard for the model to tell the difference as well. And also in the active learning tool, we also have the review page. So here we can see all the previous reviewed images, and if there are any errors, I can always just drop them out of the data set by clicking on the name here, or I can separate the classes using the menu on the right. So we've got all, ooh, let's try and see shark. Oh, here we go. So it's gone to roundfish now because it's a bit slow on the internet here, but yeah. And then finally, there's also a stats page. So over here, we can see the classification report broken down by each class, and also a confusion matrix, which Harsh will go into more detail now.
Yeah, before I move on to the results, one of the best things about the active learning tool is that it can be used for different projects as well. We've already been using it for solar detection projects and various projects, and it's also not very difficult to set up for another project. So it's not just limited to this. Anyways, for the results, the model actually gave out, these results are just for the classification network that we built. We do not have the stats, unfortunately, for the object detection that was built by them. We made sure, because there were two teams who was participating as a single team, we tried to divide the task because of the time and as well, just to ensure that we get like good results and all. So yeah, so the accuracy for the model is around 86%, which is a good accuracy, to be honest. But also it is a metric that you can think about if you have a balanced data set. So these results are basically on 300 images that the model has never seen before, also what is known as a holdout or a validation set. And yeah, there's other metrics like precision and recall. So for precision and recall, every class has its own precision and recall, but there's also a weighted average precision and recall. So the weighted average precision is 91%, and the weighted average recall is 86%. A better way to understand the entire model is, or in a simpler way I could say, is confusion matrix basically. So what is a confusion matrix? A confusion matrix is, so on the left what we can see here is the actual labels or the classes that we try to predict, and on the top is what the model predicted. So for example, let's take flatfish. We had a total of 123 flatfishes, out of which the models predicted 117 correctly and just 6 incorrectly. So that's like one of the best classes that the model could actually identify. This is also because the characteristics of flatfish are actually very easy to identify. The worst performing one is the short spine thorny head, and that's because we have around 41 images of short spine thorny head that the models seen in the validation set. And only out of those, 20 were actually predicted correctly, and 21 were predicted as rockfishes. So like we saw in the previous examples, the rockfish and the short spine thorny head actually look very similar. So it's very difficult for the model as well to guess it. So coming to the overall experience of the hackathon, we definitely had a really good time at the hackathon. We've enhanced and developed a few skills at the hackathon. So one of them majorly being teamwork. So we meet the Link Analytics team on a daily basis. Now we are used to how everyone works, and it's easy to actually create a flow of work, and make sure that things are going smoothly. But the AI.fish team, we just met 3 days before the hackathon, and it was on us how we coordinated with them and made sure that everything went in a smooth flow and nothing was disrupted. Thanks to our managing director Matt, the fridge at Link Analytics was full all the time, and so were our tummies. And the best part is obviously free pizza, beers, and everything, other things that come with it. Algorithms. We know that there is not a single path or a single choice to any solution. So the hackathon has actually enhanced our skills of doing research, making sure that we select the right algorithm, and not just end up spending days and days to research an algorithm, but make sure that we choose the right one. And time management. So yeah, we were given like individual tasks, and we had to make sure that these tasks are done in the given frame of time, because if we did not, then the entire workflow process at the ahead would just get blocked. Yeah. So as they've already mentioned that we are students and we are working as well. So we'd like to share a bit of an experience as to how it is working in an industry while studying and what advantages come with it. So these 3 points that you can see are the most common ones that I and Michael, we both agree that we get to experience. One is real world projects. So definitely what projects we work at the office is way different than what assignments we see at the university. A simplest example could be, for example, we are managing or we are taking care of data that's like in terabytes, or maybe one image is like 2K or 4K imagery, which usually we don't get to see in the university assignments, and it's a totally different experience as well. Study versus work. So the best thing about studying and working is that knowledge gained from both ends is transferable. So definitely what we learned at the university or what we will learn in the university helps us not to end up asking really dumb questions to David and irritating him maybe. And whatever we learn at work, we definitely use that to flex it at the university and ask questions, or we are more active and we can actually interact with the professors as well. Valuable connections. So working in this whole field has given us a lot of chance to meet a lot of industry experts. So for me, I just joined this company 3 months back, but I had a chance to work with the Canterbury government, and I definitely made some connections there. Michael's been here for 7 or 8 months, and he's gotten a chance to meet people at NOAA fisheries in the US, and I'm definitely sure he's made some connections as well. On a very personal experience, it's really overwhelming coming from a place, coming to a new place and not knowing anyone. But this definitely is giving me a platform to meet people, interact with people, etc. I've worked as an Android app developer for around 3 years with one of India's largest telecom industries, Reliance Jio. And coming into machine learning is almost like an industry shift. And definitely work is helping me to transit smoothly to this process. And yeah, the people at Link Analytics are really great. So it does not feel like work, it's more like a place where I enjoy going, because there's endless banter that's going on, and there's even work that's happening, especially work that's helping the environment. So yeah, I'll pass it on to Michael to share his experiences now.
So I'm going to carry on with it.
So you got to give.
No, that was awesome. Well done,
Yeah,
Harsh.
thanks.
Yeah, so my journey into machine learning has been quite different. I'm quite new to IT in general. I came from a finance background roughly, 2.5, 3 years ago. And after doing about a year's worth of IT courses, I got thrown into machine learning. And just having that kind of background and getting into machine learning as kind of a hobbyist, I think that you tend to look at it as a black box. You follow the tutorials online and lots of people's notebooks, and you just throw images in and get something out. Whereas studying whilst working, I've kind of been forced to try and understand the theory and get into the nitty-gritty and really know what's going on, especially because I have to do talks like this on it. So yeah, I just really appreciate being given the opportunity to do something like that, and getting to work on really interesting projects and with really interesting people. So yeah, thank you guys. Oh, also, last slide. So these are our social medias. If you want to find us, if you liked what we said, or if you want to ask us some questions outside of here, then you can find us there. I'll leave that up on as we go through questions. But thank you guys. Thank you for coming. Yep.